Welcome viewers. In this video we will see voltage source and current source. The details of voltage source and current source. First we will the source. The source is a device which converts the mechanical, chemical or thermal or some other form to electrical energy. Right? So the source is nothing but any form of energy into electrical energy. That is called a source, either mechanical, chemical or thermal or some other form. So the classification is available here. The source is divided into voltage source and current source. Voltage source and current source. Voltage source further divided into ideal voltage source, practical voltage source. We will see what is meant by ideal voltage source, practical voltage source one by one. Similarly, current source is again divided into ideal current source and practical current source. Right? The source, we have two types, voltage source, current source. In both voltage and current source we have ideal as well as practical. We will see this one by one. First we will go to the voltage source. In that, ideal voltage source. So the voltage source, the symbol is like this. Either the circle or this positive and negative terminals are represented. This terminal A, terminal B. So the voltage will be VAB. This will be positive and negative. It also represented by the circle VAB. So what is ideal voltage source? An ideal voltage source is a two-terminal device whose voltage at any instant of time is constant and is independent of the current drawn from it. So the voltage is always constant. It will not vary with the current drawn from it. Either the current drawn is more or less, the voltage will be the constant in case of ideal voltage source. So the circuit representation is available here. The voltage V, the terminal A and B. So the terminal A and B, the voltage will be VAB. If you draw the graph between current or time with respect to voltage, the voltage is constant. When the current increases or decreases, similarly the time increases or decreases, the voltage remain constant. For ideal voltage source, the voltage remain constant. Now we'll go to the practical voltage source. So practical voltage source, we'll see the source having some amount of internal resistance is known as practical voltage source. So the practically the voltage source having some internal resistance. So due to this internal resistance, voltage drops will take place and cause the terminal voltage to reduce. Right? So in the ideal voltage source means there is no internal resistance, but in practical voltage source some amount of internal resistance will be there. Due to the internal resistance, the voltage will drop. So due to that, there is a reduction in the terminal voltage. Right? We'll see the diagram. So the voltage source is available. This is the internal resistance R. The current is flowing. The terminal A and B, this is voltage AB. Across this terminal, voltage AB. So the graph is drawn between current or time with respect to voltage. So in case of ideal voltage, the voltage is constant. Whether the current increases or decreases, time increases or decreases, the voltage remain constant. But in case of practical, the current gradually decreases due to the drop in the internal resistance. The voltage, some amount of voltage will be dropped in internal resistance, so that when the current or time increases, the voltage is slowly decreases. So this is the difference in voltage between ideal and practical voltage source. Due to the internal resistance, there is a drop in the voltage. Now we'll go to the current source. So this is a representation. Either in a circular or in a rectangular box, we can represent the current source. This direction indicates current is flowing from B to A. If it is down, means the current is flowing from A to B. This indicates the current direction. Current direction is indicated by this arrow. We can represent either circle or a rectangular form. So the ideal current source is a two-terminal circuit element which supplies the same current at any load resistance. independent of the voltage source terminals, right? So the ideal means it will supply the same current for any load resistance. Whether the load resistance increases or decreases, it always supplies the same current independent of the voltage source, right? The circuit is represented here. So this is the current source. It is the current is flowing to the terminal AB. So the graph is drawn between voltage or time with respect to current. Whether the voltage increases or decreases, current increases or decreases, the time increases or decreases, the current remains same. The current is always constant. It will not vary with the either voltage or time. This is possible only in the ideal current sources. Now we'll see what happen in the practical current source. So in the practical current source represented with an ideal current source connected with an resistance in parallel. In case of practical voltage source, the resistor is connected in series with the source. In case of current source, the resistor is connected in parallel with the current source, right? The voltage source in series with resistor as a internal resistor, current source in parallel with the resistor as a internal resistor. So due to this, some current will be diverted here. The current is flowing from current source to the terminal A. Due to this resistor, some amount of current will be drawn by this resistor. So that net current will decreases. When the time increases or voltage increases, the net current to the terminal will decreases. So that is represented by this diagram. This graph is drawn between voltage or current with respect to voltage or time with respect to current. When the voltage increases or decreases, or current increases or decreases, the time increases or decreases, the current remains same in case of ideal. But in case of practical, what we have, internal resistance connected in parallel. So some amount will be diverted to internal resistance. So the net current will decreases. So when the time increases, the current also decreases gradually. Similarly, when voltage increases, the current decreases gradually. So this is the difference between ideal source and practical source. Due to the internal resistance, there is a drop in the current value. So in this video, we discuss about the sources. There are two types, voltage source and current source. Again, there are two types, practical and ideal. Both current and voltage source we discussed. Thank you. Welcome viewers. In this video, we'll see the electrical energy sources. What are the types available? The source which supplies the active power to the network is known as electrical source. The source from that the active power is delivered to the network, that is called a electrical source. So the classification is available. We'll see one by one. This electrical energy source is divided into direct source and alternating source, that is DC, direct current, and alternating current, AC. By using the sinusoidal function AC voltage, it's called a alternating source. This is using the DC. In that, again, two types available, independent voltage and current source, dependent voltage and current source. Independent means it is independent of the load. We will see these details one by one. Similarly, dependent. In this dependent, again, there are four types available. Voltage controlled voltage source. So this is the voltage source, but it is controlled by the voltage. Voltage controlled current source. That's a current source, but it is controlled by voltage. Current controlled voltage source. So voltage source that is controlled by the current. Current controlled current source. So this is the current source, but that is controlled by the current. So there are four types available. Voltage controlled voltage source, voltage controlled current source, current controlled voltage source, current controlled current source. Now we'll see this one by one. So the energy source we already discussed, it is having direct and alternating source. Two types available, direct source and alternating source. The direct source means this type of source, that is voltage and current, is not changing by any variation in the connected network. DC mean always is constant, but AC mean it is depends upon the frequency. This magnitude and direction changes continuously, but in case of the direct source, the DC means always the voltage will be constant with respect to the time, so that it is a there is no change, it's not changed by any variation in the connected network. In that again two type, independent voltage and current source. What is independent voltage and current source? Independent sources are that which do not depend on any other quantity in the circuit, right? The voltage source or current source always give either voltage or current. It will not change by changing any other property of the quantity of the circuit. Either load voltage or some other voltage changes, the supply voltage or supply current will not change, independent. That is, the strength of voltage or current is not changed by the variation in the connected network. It always gives the constant voltage or constant current. It will not affect by affecting some other parameter. That's why it is called a independent. Always gives the constant voltage or constant current. Now we'll go the dependent voltage and voltage source and current source. What is that? The source whose output voltage or current is not fixed but depends on the voltage and current of another part of the circuit. Right? So due to the load or some other parameter, any changes that will reflect in the source also. The source voltage and current also will be affected. The source voltage and current is not constant. It will vary along with the variation of any other part of the circuit. In any other part of the circuit, if any variation is there, then source current and voltage also changes. The strength of voltage or current changes in the source for any change in the connected network. So the previous case it is not changed, but here due to the second type, dependent means any change in the network will change the voltage and current of the current source also. So it is represented by the diamond shape. All other represented by the circle. Independent source means represented by circle, dependent source represented by diamond shape. Right? So this dependent voltage source again classified into four types. We will see these types one by one. So first we will see the voltage controlled voltage source. See the diagram. So this is the voltage source, terminal AB. So due to dependent, it is represented by the diamond shape. The terminal AB, the voltage is VAB. The another part we have one resistor is available. The terminal is CD. The voltage is VCD. So this is voltage controlled voltage source. So this voltage will control the supply voltage. That is, this VAB is proportional to VCD. VAB equal to proportional to VCD. Voltage controlled voltage source. If any changes in the VCD, this part, that will change the supply voltage also. So VAB equal to, while equating, we need to introduce one constant, K into VCD. This is constant. So this is called a voltage controlled voltage source. This voltage will control the voltage source. Either it will increase or decrease. So in the above circuit, the voltage across the terminal AB is dependent upon the voltage across the terminal VCD. The VCD will control the voltage of VAB. Then the next type, voltage controlled current source. So this is a current source that is controlled by voltage. See, this is a current source. AB, terminal AB, the current flow is IAB. Another part what we have, one resistor is available, CD. The voltage is VCD. In voltage controlled current source, the current of the source IAB depends upon the voltage across the terminal CD, that is VCD. Right? So that it is called a voltage controlled current source. So the current IAB is proportional to VCD. The VCD will change the flow of current. While equating, we need to introduce one constant, that is this symbol IAB equal to VCD. This symbol is nothing but a transconductance because it is I by V. V by I is resistance, I by V is transconductance. The unit is mho. In case of resistance, it is the ohm. Here, mho. So this is nothing but a voltage controlled current source. Any change in the voltage will change the flow of current in the current source. Now we'll go to the next type. So this one, current controlled voltage source. So this is a voltage source. This is a voltage source is available. It is controlled by current. Current controlled voltage source. In the current controlled voltage source, the voltage source of the network depends upon the current and the current of the another network. So this is diagram. So we have voltage source is available, VAB. Here one resistor available, the terminal is CD. So the current is ICD. So this current will control this voltage. So that it is called a current controlled voltage source. VAB is directly proportional to ICD. This current will control the voltage. So VAB equal to R into ICD. R is the constant. I will go to the next type. Current controlled current source. So this is also current source controlled by the current. Current controlled current source. So the current controlled current source means the current source is depend upon the current of the another branch. So this is one current source is available. This current source is depends upon the current flowing in the resistor. This terminal is AB, IAB. This terminal is CD, ICD. So this ICD will change the performance of IAB. So IAB is directly proportional to ICD. So IAB equal to beta into ICD. Beta is the constant. So current controlled current source. So in this video, we discuss about the energy source. Basically two type, direct source, alternating source. Then dependent, independent, voltage and current source. In dependent, again four types, voltage controlled voltage source, voltage controlled current source, current controlled current source, current controlled voltage source. There are four types. These types are we discussed. Thank you.